Hi there. Welcome back to COG 376. We're going to do another code demo today. If you're missing lecture, sorry. We've got a lot of programming things to get into your tool belt before we do some more of the more advanced stuff. But I promise there is still some interesting language stuff embedded in these code walkthroughs because it turns out instructions in code and language have some things in common, and so do some of the abilities we gain from playing with new things. So today we're going to focus on two things, one thing majorly and one thing as sort of an interesting side concept. Let's open idle. I'm going to open a new file. Just going to save it straight away. Make it a little more well, you can't see the left side, sorry. So I'm going to save this into demo.py for this particular walkthrough. Okay, now again, follow along in idle if you can, and feel free to pause and play with things. Again, having the shell available is our friend. So you open the shell. If it wasn't clear, you open in idle for Python. You open the script window from the file drop-down menu, which I'm not able to show you over there. Sorry. And you open the shell from the run drop-down menu. So, what are we doing today? Well, a couple of different things. So last time we touched on how to import things, and I'm going to start with that as like a simple exercise. What if we want to do something randomly? Sometimes, especially when we're dealing with, say, a chat bot, for example, we know that Eliza has some basic things it can say when it's not really sure what to do and when it doesn't have a pattern to match. So if we're going to do something like have a default set of things to say, you don't always want to have the same exact words every time. It kind of breaks the illusion and pulls the user out of the experience of interacting with this sort of language bot. So if I want to do something at random, for example, select a response at random, I can import the random package. I'm going to do it in the script, import random. If I do that here, I can show you how it works. So we'll import random in the interpreter just to get it going. So now if I do something like this, random.choice of 1, 2, 3, 4, and 5, I'm giving it a list, right? Random.choice of that list is going to pick one at random. Aha, yay. Random just means equally likely chance. Hey, look, it's always 4. No, equally likely chance that any one of these will be picked. Now, human brains are not great at random, although I am a little suspicious. Why are we not getting the 1? We got the 5s. It doesn't matter. Look, the promise of random is that it is equally likely. You're just as likely to not get a 1 very often as you are to get a 4 6 times in a row. So this is random. Now let's recontextualize that in the form of chat bot. So let's say we want to make a list of greetings that we think are applicable. We can do hello. We can do hi. We can do hey there. We can do, hey, what's up? Right? And here are just a set of viable greetings, right? And if I want to pick one at random, I can print, we'll just do one. So random.choice. And remember, you are giving it the entire list. So we'll do random.choice of greetings. If I run this, what will it look like? F5. Hey there. Run it again. F5. Hey, what's up? What if we do it 3 times in a row? By the way, remember, I'm doing a lot of copy and pasting. That if you aren't sure how to copy and paste, you should absolutely become sure how to copy and paste. Usually in Mac world, it's Command-C. In Windows, it's Control-C. And that picks up text into the invisible clipboard of your operating system, and then lets you plop it back down. Really get used to doing that. It also hopefully makes some of what I'm doing make more sense. So let's run this. F5. Hello, hey, what's up? So you see how it Hey, what's up? Hey, what's up? Hey there. Well, man, it sure was left to pick some of the double. Hello, 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 what's up? There we go. 3 different ones, finally. That's just randomness. This is cool. This is a good thing for you to know about. There are lots of other tools in the random kit. I think it's random.random will give us a random integer between, not integer, random floating point value between 0 and 1. You can probably think of a few fun ways to use that, but for now, we're not. So that's the first thing I want to touch on. So the idea of how to make something random. We will use this again in the future. Randomness. And as usual, when I upload this document, it will have a lot more notes in the comments. So now, the next thing I want to get into is a more fundamental and a pretty powerful thing that is just going to make our lives that much easier. This is the kind of thing I would maybe wait to do until, maybe not even in the course, but it makes things so much better for us that I feel you need to understand how it works. So we're going to get into dictionaries. Okay. So far we've seen a way to keep track of a few different things that is a list, right? So I'm just going to name a variable a list, and I'm going to make it 1, 2, 3, 4, right? So if I have this list, how do I get things out of it? Well, let me define it, a list. And if I want to get something out of it, I go a list sub the index, right? The numerical address of the thing I want out. The 0th item, the very first thing, is the number 1 in this case. The 1th item is 2, right? So this is a 0 beginning address book, right? It is all numerical. What if we want to do something that's a little more human friendly? We can see how the numerical thing is very nice for a computer to have just the exact numerical addresses of things, but we can do things that are kind of a little more human functional. We can use something called a dictionary. So I'm going to make something called a variable called a dict. Oops, not diact, dict. Dictionaries are a little different. Instead of using just a bunch of values at given positions in the list, instead it does key value pairs. So the key is a string, and we can have it be something like first item. So the key is a string that you give to it, and then colon means, hey, I'm going to define what's in there, and let's say 10 is in there. And then you put a comma, similar to in a list, but now you see this is a key colon an item. Or a value. I switch the words item and value a lot in my head, so sorry if that bubbles out here. So let's put a bunch of things in here. Second item is 20. Third item, we're gonna stop calling it. We can break away from the pattern of doing things in order, because that's not what we're doing anymore. We're putting things into specific named locations. So let's say Bobble has 30, and then potato chips contains 40. Just like with defining variable names, you can use whatever string you want as the keys. Okay, let's do one. How do we get things out of a dictionary? Very similar to the way we get things out of a list. So if I go a dict sub, you put a string in there this time. I want the first one. I want whatever's in potato chips. A dict sub potato chips. Whoa, we got the 40 out. Okay, so this is a better way to think about storing collections of information if our information is kind of different, right? So I'm going to drop some things over from my notes code over here. Just to demonstrate how this works, and let's run it just real quick. We got our greetings, our random greetings. We have one is the first thing in a list, but we can also get the 1th item out of the thing called first out of the dictionary. We can get the 3rd entry out of the list, sure, the last thing, or we can get potato chips out of the dictionary. All doing the same. It's demonstrating that it's a similar way to interface with it, right? But instead of having to know the numerical address of something, we can know its name. Names are powerful. Names mean we can more easily deal with something. So now, just a quick theoretical aside on how does this work? Well, I'm not going to make you, this isn't computer organization. I'm not going to make you understand all the concepts up and down, but it's nice to know. So it works actually quite similar to a list or an array in many cases. But instead of having to know the exact, position in the address book, instead the code, the system, the programming language will just chop that string up into an integer in some way. Integers, as we know, are these are the whole numbers that work for indexes. So again, I'll leave some notes in the finished product, but the idea is that under the hood, this thing is quite a lot like this thing. It's just got a lot more spaces, and the indexes are chopped up before they go in. Take a computer science class if you want to learn a lot more about this. So, sorry, I'm getting some loudspeaker activity outside. Okay, so let's kind of use a dictionary for something a little bit more interesting than this little toy example. Dictionary of a phone book entry. So, let's define something that's a little bit more, will make more sense, right? Sometimes you have a lot of related information, but that is of different types. So, for example, phone entry. And now, something I want to note is that when you're defining a list or a dictionary like this, it's useful. Hang on. Okay, sorry. It's quite useful to you can break it up the white space so that you don't have to define everything on a single line like this. You can actually span several lines. And here the need of Python for things to be indented properly is a little bit relaxed. So as soon as it sees, hey, you've got a curly brace open, it doesn't get all finicky about the indentation for the duration. So let's say we're going to make a phone book entry. Let's do me as a phone book entry. First name is John. Okay. Last name is Linstead. Area code. I'm going to be real finicky about it, just so it's very readable. Area code is going to be 315. That's our whole Oswego code. Prefix. So this is the second set of numbers, 312, second set of 3 numbers. And then line number. If you didn't know these technical terms, welcome to the party. That is how a phone number is split up. So, let's look at this. You can see how this is all information that's different. It has different names, but they're all related because they're all referring to me, this one person who exists, right? So a single entry dictionary might have all these various values associated with it. So we can go phone entry sub. I want to know this guy's first name. Well, that's John. Phone entry sub. Well, what's his extension? Okay, well, that's line number. There we go, 6608. That'll get you to my office. Sorry, no one's in there. It's currently unoccupied. So, this is how we can store lots of information that's all connected in some way in a space, but we don't give up the ability to name and label and organize that information. In a list, you have to just hope that, you know, anything you're doing, you're going to know, you're going to probably do it to all of them and just do them in sequential order. Whereas with this, you can get a little more fancy. You can say, I'm going to need the area codes of every phone book entry item, every phone book entry dict. So, let me pull over a couple of examples, just so we can leave our little trace. But another cool thing about this is that you can actually address dictionaries from a variable. So this is actually quite nice. Let's say we don't necessarily know up front. We might have a slightly more complex thing going on, say inside of a function that we define or something like that. And we want to be able to later on pick which item we're trying to dig out. You can assign, so here's a variable I've named looking for, and I've given it area code, right? That happens to be the key to this. So now this variable looking for contains the key for area code, named area code. So if I want to print phone entry sub looking for, now this looks different, right? It's not a literal string that we've put into the brackets. Instead, it's a variable name, which will get evaluated. It'll come and say, oh, I have the string area code. And then the phone entry dictionary will say, okay, I can find that. Let's prove it. I'm going to just run the script. We pulled out the area code, 315. Nice. Little less labeled here, but it does it. Does the thing. So these are the ways that dictionaries are very flexible. They allow us to do things that, you know, if you were trying to organize things in a list, you might have to know a lot about how that list was built and how, you know, what order things occur in. Whereas in a dictionary, it doesn't matter. You know the names of things. So, just a demonstration of what I was showing before. You know, we can, if I say, show me what's inside of phone entry. Come on now, type, thank you. What's in phone entry? It's this dictionary. I'm just going to copy paste that just to show you. You can define it all in one line if you want. So let's say, so white space is flexible while we are defining lists and dicts. If I define a different phone entry, just like this, phone entry 2, then what's going to be inside of these is going to be the same thing. So let me just go ahead and print them. Print phone entry is the first one that we did up there. Print phone entry 2, second one there. Let's run it. I know it must be saved. I thought I did. So you're seeing that these are the same. Even though the white space looks wildly different, they are identical. Just remember this. This type of writing is good for you, if not me, right? It will help you understand what's going on in your code. If you don't, it's fine. The system will still read this just fine. But you got to admit this is a little bit harder to recognize what exactly is happening. So one last kind of cool thing is that you can actually tell if these things are identical by asking, does phone entry equal phone entry 2? Remember, equal is asking, that's sort of the Boolean question of, are these the same? Well, let's find out if they're the same. Oh, they're the same. Everything about them is the same, so they evaluate the equals as true. Neat. So, carrying on. Let's see. Another cool thing that you can do with dictionaries can get the list of keys using phone entry, or well, no, I'll write it as dict.keys. It's a function, but it returns a something similar to a list. Let's do it. So print phone entry.keys. Okay, sorry about this. There turns out there was a peace rally right outside my building, so I paused to go have a look. You can see the previous recording from the first half is now landed right there. Where were we? Let's see. So, we can get a list of keys using dict.keys. This is pretty cool because this allows us to grab the keys list and do certain things with that. For example, if we want to say instead of doing accessing everything in a dictionary, sometimes we want to iterate through everything in a dictionary like we would in a list. So, for example, one nice thing that we can do with this phone entry.keys is we can say, let's see here. Similar to how we would make an iterator, that's not even the right technical term. The same way we might make a for loop for a list, we can make a for loop for a dictionary like this. So for k, I'm just remember in a for loop you define some variable to get whatever is in a set. We'll do phone entry.keys. So for what this is getting at is for each key in this set of keys, we want to do something. For example, print. We can print both the key itself, which is nice, and the phone entry at that position, at that location. We can use this variable to say, I'm going to get the key, the thing that's in there, the item that's in there, the value that's in there. I'm going to use the key to go get it, but I'm also going to print the key out. So let's watch what happens with this. First, John. Last, Linstead. Area code 315, etc. It did it. It did that thing. This is a way that we can move quickly through an entire dictionary if we feel so inclined to. So, another thing about dictionaries that's very useful is that you can actually just add items on the fly. So adding items to dictionaries is easy. But I want to show you how it might break first. So we know roughly what is in one of these dictionaries, right? The dictionary called phone entry that we've labeled. We know what's in there, right? If I say phone entry pets, so that's a key that we personally, humanly know is not in there. What happens? It blows up. It says key error pets. That's fine. When it throws an error, that means we got to find a way around it, right? Oftentimes, we might not know if a particular key is in a dictionary or not. So, we'll talk about a way we can check that shortly. But I can also say phone entry sub pets. Sorry, I gotta get my mouse out of the way. I can assign something to it right here. I can say in that position of the dictionary called pets, put a little bit, my cat. Oh, whoop, not save. Just hit enter. So now, if I do this same line again, there's something in there, isn't there? A little bit is there. Good. So now if I just dump the whole thing, there it is. So, oops, sorry. We can see, I'm gonna just copy that over from elsewhere. When we first try, it blew up, but then when I put something in there, it worked just fine. So this is great. For one thing, this is great because we don't have to define anything up front. We can make an empty dictionary and then just start throwing named things into it. That is really flexible. I want you to understand that is a very flexible way to be able to throw information around inside of a program. And as long as you're keeping track of what the keys are, you can always get all that information back out. It's pretty powerful, especially when you're talking about things like knowledge representation, which we'll cover in the future more directly. For now, let's see. We might not always know if the thing that we want is defined yet, right? So checking if a key is in the dictionary. So we might want to do something like this. This is a pretty cool thing. You can use this same keyword in that we used for building this loop, right? This says, for each thing that's in this list or this large box of things, I want to do something. We can also use it as a question, as a condition check. So we can say something like, I'll do it right here. Is one in this box of this list of numbers? Is 1 in there? Yes. Is 5 in 1, 2, 3, 4? It is not. That's how you use it with lists. This is saying, I want to see if this value is in this list of values. With dictionaries, it's slightly different. It will tell you if that key exists. So if I did something like, I'm going to just copy this over. Is A in this little dictionary I made? A has 1, B has 2, C has 3. Is A in there? The answer is yes. So this allows us that sort of data verification thing. So we can do something along the lines of, is pets in phone entry? Yes, because I have defined a pet. And another interesting thing here is that because this is a list and this is the dictionary, you can kind of do it either way. You could also do print is pets. I'm doing print, but well, we don't need to do print, and that's just confusing things. You can just enter things in the command or in the interpreter. Pets in phone entry, just to recap. So this works. This says, is that key there somewhere? You can also do pets in phone entry dot keys. As we looked at before, we can pull the keys out. It does the same thing. Just so that this is just to demonstrate to you what that really means, right? So we are getting the phone entry item dictionaries, all of its keys, and then we can ask, is pets among those? But the shorthand is just this. So what this allows is we can now do our little data verification thing. For example, here I'm going to copy over some of the work we've done into this little script, just so it makes sense all together, and we can have a little trace back. And again, I have a lot more comments in the one that will be posted. So this is just for our working document. So real quick, run it, make sure none of that blows up. Yeah, false. Okay, lots of trues and falses, etc. This is there, this is not, this is there in 2 different ways, right? We can use this information to check something, right? So for example, if this phone entry has an entry for pets, so if pets is in phone entry, then we can do phone entry subpets. We can print it out, right? That one's going to succeed because we've defined, my cat is a little bit. But if we want to check the same phone entry for children, something I have not defined because I ain't got no kids, so if children is in phone entry, then we'll print the children that are listed there. So if we do this, if I follow it, F5, we see a little bit, but we elegantly dodged the fact that children would blow up if I tried to talk to it directly. So we'll apply this in a small scale in a minute. So how can we use these? this is kind of interesting in a lot of ways. It's a stronger way to represent knowledge. Knowledge is often a set of relations, right? It's a set of information that is connected to each other. Birds have wings. Birds can fly. Birds are, now I've forgotten what kingdom. I mean, mammals, whatever, animals, avian, something. Whereas donkeys are not avians. Lots of information is connected in that way. We have patterns, we have concepts that are all related to one another, and dictionaries make it kind of nice for us to be able to relate information a little better because it's connecting two different ideas at the same time. A has one, okay, but more importantly, John has pets. What pets? John's pets is little bit. It's a way of networking language together, information at this sort of language symbolic level that we can make use of. So I want to show this is how we can build a little bit better knowledge base kind of on the fly. So let's do this, and we're going to use the example from last time, our little item parser, but we're going to change a little bit. So to make the item parser work, so building knowledge using dictionaries. Building knowledge on the fly using dictionaries. So let's do a couple of things. We're going to import RE because we need the regular expressions to make the little parser work. We're going to grab, you know what, I'll just do it on the fly. So a couple of things I'm going to have to edit above myself in a minute. So define, we're going to do item parse just like we did before, right? If you recall from last time, and it takes the idea user input, right? That's the argument to the item parse function. So what are we going to do in the item parser? Well, first we're going to take the input and run the pattern over it. What is the pattern? Remember, it's defined right here in the function like we did last time. Pattern is, oops, make sure that's indented properly. So match is, we're going to go and find, is this I have some number of something pattern, does that exist in the user input? Okay. So if we get a match, so if match does not equal none, we're going to need to print it, right? So the basic thing is print it out. Print it, print item. You know what? I'm going to just copy that line. Maybe I should have just copied it all to begin with. It's fine. So make sure my indentations are not too messy. Let's see. And then the previous way we had this was, if I did find a match, I was going to print it out and kind of regurgitate the information I extracted from it. Otherwise, I got nothing. Let's just run this. I'll go ahead and run the whole thing. And now everything should be defined, so we can play with item parse, right? So item parse. We're going to say I have a dog. No, sorry, it needs numbers, right? I have one dog. Gotta finish. Item parse. I have $10. Dollars. Count 10. Cool. What we can do here, what if we wanted to keep memory? What if we wanted to keep track of this information, not just regurgitate it, right? In this code, all we're doing is printing it right out. What if we want to keep track of it? Well, we can define a dictionary called memory, and we can start, it's empty. There is no memory yet, because you haven't been told anything yet. And from here, every time we get information, remember, match 2 is the kind of thing, and match 1 is the number of thing, right? So we can just do this simple thing. Memory sub match 1. Remember, or sorry, that should be match 2. That's a little bit, let me do something to make this a little more explicit. So instead of dealing directly with match, let's do, so if the match exists, instead of printing it straight away, let's grab out its information. So type equal, no, not time, that's a kind equals match sub 2. Count equals match sub 1. Just make it a little easier on ourselves. We've now pulled those same things out into actual variables for the duration of this little function. So kind has the type of thing, and count has the number of that thing, right? So the number of things was the first thing, and the kind of thing was the second thing. So instead of, and also we can fix that up here. I'll just make this clearer. Kind, count. Yay, life can be simpler. So memory, kind, equals count. So again, this presumes that the match was not empty, so all of these things should work. They won't blow up. Match 2 goes into kind, match 1 goes into count. So I have 1 dog, so kind is dog and count is 1. I'm storing that information in memory. Memory lives up here, and I'm piling something into it. Now, memory should start to fill up with stuff. Let's watch. I'm going to grab out 3 lines that are similar to what we did before about the capybaras and friends. We're going to run that item parse. So now, let's run it. Boop. Okay, so it's still regurgitating the information. I've told it 3 things. Did you know I have 2 cats? I think I have 30 dogs. I have 500 capybaras and I don't know what to do with them. So now I can look what's inside memory right now. Memory sub capybaras. The number 500. We have saved the value of what was said to us. This system just took human language and stored relevant information from it in a memory bank. If I just dump memory entirely, cats, dogs, and capybaras. Fantastic. So, this is a really useful set of skills, I think. This is, I hope you're starting to see how this kind of data structure is just that much more human. We understand it better, but it's also a little bit more like how we relate concepts in our minds. It's all very much more human related, human relevant. So I'm gonna copy over those little bits. So now, final exercise for this. Let's put this all into a loop like we like to do at the end of these little demos. Put it all in a main loop. So I'm gonna do this from scratch again. So first we need to declare the memory. Memory equals an empty set of information. Done is going to be false. Remember, done is our condition for when the loop should stop. So while not done. First, let's do a little fun thing. Let's pull in what we did from the beginning. Let's get a random greeting every time the system loops, just for funsies. So random.choice greetings. Cool. First thing we do is print a random greeting. Then we're going to grab the user's input. User in equals input from, I'm going to give it a little bracket input line. Okay, so when we get the input, we're going to do a couple of different things. So the primary thing we want to do is, as long as this information, the user is going to put in mostly just these kinds of lines, but I want to have a couple of spaces so we can check things on the fly while we're doing it. So we're going to check for those things first. If user in dot lower, just so that it's lowercase, so it'll match no matter what, whether the user types. If they type done, then we're just going to say done equals true, and we're not going to do anything else. Now here's the clever thing you may not have seen before. You can extend if statements to have multiple possible conditions using something called elif. It's a combination of else and if. So if the user's input is the word done, then we're going to set done to true, and we're going to get out of here. If the user in dot lower, if that's equal to memory this time, then I want to see print whatever's in memory. And then finally, final case is the normal one, and that's going to be, we're going to run the item parse function on user in. You ready to interact with our weird chatbot? Let's do it. I'm going to run it from top to bottom. It's going to do a lot of printing, and then, hey, our prompt begins. Hello, I have $5. Item, dollars count 5. Hey, what's up? I have 0 dogs. Item, dogs count 0. Hi. This one's finally true. I have 1 cat. I have 5,000 capybaras. I love those things. They're weird. So, hello. Hey there. It's being nice. It's greeting us. It feels a little bit animated. It's picking different ways to greet us, although it doesn't really understand that you wouldn't continue to greet people forever. So, and let's find out what's in memory. Remember, we can just type the word memory, and that's a special case of the user's input. So we're going to print what's in memory. What's in your memory? Dollars 5, dogs 0, cats 1, capybaras 5,000. The system is listening to us. It's listening to our natural human language. It's processing it into something that it's storing information based on. You could see how then you might access this memory and pull it out and slot it into sentences. Say I asked, how many dogs do I have? I could pattern match that. And then it could say, you have this many dogs. It would easily be able to construct that. So that's it. Again, as always, you should check this out. You should check out the code. You should follow along with it. Try things. Play with things. Check the video again if you get kind of confused and tangled up on any of it. And as always, I'm around. So, all right. Thanks so much. Oops. No. We don't need to say that. Thanks so much. And take care.